Alrighty, welcome back. So, let's do a quick recap on what we've gotten so far. So far, we've gotten downloaded our free sprite sheets, Mythil Age, Time Fantasy, Tiny Adventure Pack, and the Zelda Like tile sets and sprites. We've talked about how to set up our characters' sprite sheets to have the individual sprites split up in the Unity here. We've talked about the pivot point, and we have implemented a few scripts already, or at least started on writing our few scripts. We've started on writing our character controller scripts. So we have our character movement, which is going to control all of our character movements. Our character movement animator controller, which is going to control all the animations. A base character controller, which is going to control the animation portion, our basic character controller here, which is going to control all of the inputs that's coming in, whether it's going to be from the input manager or if it's going to be an AI script. And that's just going to pass everything on to our character movement. And then we implemented our input manager character controller, which is inherits from the base character controller, and it uses the input managers. We have come through and in our project settings, input, and renamed several of our movement keys here. We've used the horizontal, we've used the vertical, we renamed the fire 3 to run. And why do we have two runs? Space. Oh. So we have two sets of runs here. This one we're gonna have to change to toggle run. And that was the last one. So we will change this to toggle run. Alright, so now let's take a quick glance at our scripts that we have so far. So right now, here's our character movement script. Since the last time I've gone through and added some comments, so it's about the only difference you'll see is the comments have been added. So our character movement script is inheriting from Mono Behavior, which is a Unity class that we use to write our own component scripts. We have a float here for our movement speed that we've given a tooltip for and serialized it so it shows up in the Unity editor. So if we select our player character here and look at character movement, here's our movement speed, run speed, and it is running. So movement speed, if you notice, it's got a little tooltip, the speed at which the character moves in the game world. Run speed also has a tooltip here. And that'll be our movement speed and our run speed. We've made a public blue is running, so we know if the character is running or not. We've got a direction here for the movement, which direction we want the character to be moving. We have this variable here for set movement direction, so we can pass in the movement direction we want to set our movement direction to. I'm going to change this out. I'm going to get rid of this set movement direction. And we are going to go to using a public property instead of a function call to set our movement direction. So public vector2 movement direction with your brackets. And now we're going to do the get. And this here is just something that's new in coding. Equal signs greater than and movement. So all we're saying is we're returning the and movement direction. And then for the set, equal signs greater than, we're going to say the movement direction equals, we're going to say if the character is frozen, to set that to vector2 0. Otherwise, we're going to set that to the value that was passed in to this variable. Again, the equal greater than signs here are just shorthand for having all your open curly closed brackets. It only works with one lines, just so you know. Because we have our character is frozen variable here that we have, and then we have the public one for is frozen, and we've done the shorthand for the get. It just returns the value of is frozen, and then we have our set. You notice we have to use curly brackets because we've got more than one line here. So we're setting our frozen to the value that's passed in, and then we're checking if the character is frozen. We are checking and making sure that our movement direction is set to vector 2.0. That's just to prevent when we decide to freeze the character that the character doesn't move. And then I have also updated and added this public balloon is moving to return whether is frozen is equal to false and our movement direction is equal to 0. So what happens here is it comes in and says, okay, frozen equals false. Yes, that is true. So the character is not frozen, and our movement direction variable is greater than vector2.0. Yes, then we can, or I'm sorry, is not greater than, does not equal vector2.0. Then yes, the character is moving. So then it'll return true if is frozen. If the character is frozen, it'll return false. If the movement direction is not vector2 0, which means that we've passed a direction in to move our character around, it'll return true. Okay, and then we got our rigid body that we're using the physics system to move our character around in on the screen. I've added this here thing called regions. That's just so I can collapse them and move them out of the way. So here we have the awake, and since awake is only going to be one line, we can use the equal greater than sign and do the rigid body equals get component rigid body. And then also we did the same thing with fix update, and I got rid of all the curly brackets and just made this one line or two to be update movement. So we can close this down, and here is our update movement function. We're going to move the character around in the game. So first thing we do is we check to see if the characters are frozen. If it is, we're going to say movement direction equals vector2.0. Now we're going to say we're going to look at our speed. We're going to check to see if the character is running. If the character is running, we're going to set our speed to the run speed. If the character is not running, we're going to set it to our regular movement speed. And then we're going to sit here and we're going to check the rigid body velocity to our speed times time.delta time times the movement direction. So all this does is we're taking the direction that we're wanting to move our character and multiplying it by the speed. So we're adding our speed value into the equation, and then we're multiplying that by time.delta time. And that is just so we can have this frame rate independent no matter how fast or slow or advanced your hardware is. It's all going to run and move at the same speed. You're not going to have one moving faster than another computer. So now let's come over here to our character movement animator controller. We haven't done anything with this yet other than created it and got our animator. In fact, we're going to do this to expression body because this is going to be a one line thing, right? Actually, no, we're not, because I'm gonna add some stuff here. I forgot, but I added the Unity methods here for that. So we're gonna be coming back to this script because we have to set up all our animations. Now we're over here to our base character controller. So right now we have that it's requiring this script here. And we have the Unity methods. We're going to say we're going to get the character movement script. We're going to update movement. And then we have this abstract class method called update movement. So that means anything that inherits this base character controller has this update movement. If you come in here, we've got our input manager controller that inherits from our base character controller. We've got a private balloon here for toggle run that we made a serialized field. And the serialized field again makes it so it shows up here in the Unity editor. So we can tell it whether we want it to toggle or not on the input manager. And then because we said, hey Unity, or hey, this class has to have this method. We have to implement this method somehow to update the movement. So in our input character controller, we've implemented this update movement method. And we say get the vertical and horizontal movements from the input manager. So we came over here to the input manager and said, input manager, what is your vertical movement keys? And we have up, down, SW, or uh, on the joystick, on the gamepad, we have it set to the y-axis. And then our horizontal, of course, is left, right, AD. And if you look down here on the joypad, it's going to be your x-axis. So we're storing those as float variables. And then we're checking to see if our character, if we have it to toggle and run. If it's not, then we set our run button to, we get the run button and we say, hey, Unity run. Character is running. We set it to the opposite. So, because we're toggling the run button, right? We're going to say, all right, we're toggling our run button. So we're going to say, hey, we're going to run, run, right? Else, so we're not toggling the run button. That means we're going to have to hold the button down. That's what this get button here is. So we're just setting the character movement running to input that get button run. All right, we're going to tell the character to move. So we're going to say character movement, set movement direction. Now remember, this was in our character movement class. We had that function that we got rid of. That's a set movement, because we're changing it over to movement direction here. So we got to fix that. We're going to say character dot movement direction equals new vector 2, and then we're going to say our horizontal movement for the x and our vertical movement for the y. We're going to save that script, and when you come in here to Unity, press play. Now pressing the left key, pressing the right key, and if you notice here we have toggle run to true. So if I press the shift key, which is what we have set to our run, our character moves a lot faster. Now if I have to press the shift key again, and he moves slow, he quits running. And if we turn this character toggle run off, I hold down the shift key and my character runs. I let go of the shift key and my character goes to his walking speed. That is exactly what we want. So, now, excuse me. Alrighty. So now we're going to come back here into the code and I'm going to update our character movement script. We're going to come down here to our update movement method. And let's see here, we are going to add a little bit. We're going to add some comments first. So we're going to say if the character is frozen, set the movement direction to 0. And I can't spell tonight. To 0. Alright. We're going to say get the speed based on the character running. And we're going to add this comment here that says update the rigid body velocity. Alright, whoops. Rigid body velocity based on the speed and movement direction. And right here we want to add in, so we're going to normalize this vector. So right now our vector can be anything other than 0 and 1, and we kind of don't want that. What we want is our character to have a movement direction of 0 or 1, or 0 and -1. So we're just going to say uh, if our movement direction does not equal vector2 dot 0, we're going to do movement direction no, and movement direction, because we're using the local variable dot normalize. Makes this vector have a magnitude of 1. So we'll comment this out real quick. I'll show you the difference and why we're doing this. Oops. Actually, I'll just cut this out real quick. If you come in here and we press play, make our character to be running, Now if you see, if we hold both the keys up, if we're moving in both directions at the same time, you see how he's moving quite a bit faster? So now, if we come in here and put this code back in, show you the difference here while we're normalizing this vector. Oops, shift to run. See, now he moves at the same speed whether he's moving vertically or in both directions. That's all that normalizing that vector does. Alright, so now we're going to update how our base controller works. Because I want to be able to implement some of this code that's here across all of my code, right? So we are going to update how our base controller works. So here in the base controller, we're going to copy over this serialized private field for toggle run. And we're going to move it over here to this one. We're going to put a comment here. We're going to say, should the run be toggled or keep rest? Or button held. Alright. Let's see here. My movement direction is going to be this. So we can do this to a expressionless body. Our update. So here is where we're going to do some nifty little things. We're going to say set direction and pass in this new method that we're going to make with update direction. Okay. So come down here and make these two methods. We're going to say protected, abstract, because I'm not going to implement it here. We're going to make this update direction be implemented in our other code. So protected, abstract, update. Oh no, we need a return type. So our update direction, we're going to update with a vector 2. So we're going to return a vector 2. Update direction. Alright. And we're also going to update a right click here, create method, create this update direction method, or the set direction method. And in our set direction method, we're going to say, in our set direction method, we're going to say our movement module. And we're just going to say direction. Alright. And we're going to say, we're going to take our movement module. So character movement dot movement direction equals the direction that we passed in. Alright. Now we're gonna create another one for update running. So we're gonna say set running, and we're gonna pass in the set running to another variable here, update running. And we're gonna copy this update direction method, and we're gonna make it update running. Alright, now we're gonna copy this set direction method here and change it to, oh, not a vector 2, this is gonna take a Boolean value. So what we're gonna do is change this here to a boo value, and we're gonna rename this to is running. And instead of movement, we're gonna say character movement dot is running. Alright, that takes care of that. I'm give me a second, let me go back over my notes here real quick. Alright, so now we have to come, oh, we didn't create this set running, see? That's because I didn't rename it to set running. Why is this create overload for set running? Function balloon. Oh. Hut. I know what I did wrong here. There we go. I forgot my curly brackets. Alright. So we're gonna have to implement missing members. Update direction and update running. Alright. So in update direction, we're gonna do this. Control V. And we're gonna return a new vector 2 vertical or horizontal movement, vertical movement. Alright. Now we're going to Control X, we're going to copy this. Control V. Delete this. Why is toggle character run? Oh, it's set to a private. So we need to change this to a protected. So protected means anything that inherits from this class can utilize my run. So now this is correct. So now we need a variable. Actually, we need to store this variable. So we need to add up here. We need to add a private balloon. M is running. Is One thing. Why is it not taking it? Oh, there we go. So we're gonna say, instead of character movement, we're gonna say is running does not equal is running. Else we're gonna set is running, and then we're gonna return is running. And actually what we're gonna do is, watch this. We're gonna do this right here. Return. Oh no. Yes, we're gonna return just like that. Alright? Okay. What other problems do we have? Implement missing members. Oh, we didn't update movement. So come back here to our base character controller. We are no longer using this class update movement here. So we can delete that. And we can delete this override update movement. So now our character class should be working just as the same exact way that we thought about it. And we're going to do something else here. So we have this float, right? We have to return this new vector. So what we're going to do right here, we're going to say vector2 new direction equals vector2 dot 0. And we're going to say if our b for our vertical is greater than 0.1 f. So if we are moving, if the up direction is pressed, what we're gonna do is we're gonna set our new direction dot y to be 1. Control C. This is so we can implement our facing direction later. If we're gonna say if it's less than negative 0.1, we're gonna return -1. Alright. So this is if the down direction is pressed. We're going to copy this and we're going to change this from if to an else if statement. And we're going to copy all this. And we're going to paste it. We're going to say if H, so H is greater than 0.1, we're going to say X equals 0.1. And if you remember right, positive in unity on the X axis, whoops, is to the right. So else if h is less than -1, which is to the left, we're going to set our new direction to -1. And what is our error here? Oh. And then we're going to return this vector instead of returning a new vector. Return new direction. Simple as that. Alright. Now if we come back over to Unity, because we made a change, we're going to check to make sure our change works. Yep. Pressing the shift key still toggles my run, and my character still works as planned. Okay. So now we have to do some sort of checking for our animation directions, because right now we have our character is facing to the left and facing to the right when he moves, but you notice that he's facing one direction. He's facing down direction. And if you remember correctly, when we set up our animator here, we have direction X, direction Y, and it is moving. And we set up our idles for idle down, idle up, idle left, and idle right on this bunch tree depending on our direction X and direction Y. So let's implement this into our code. In order to do this, we are going to have to implement our character movement view here. Whoops, wrong character movement view. Our character movement view here. Oh, I was in the right one. Our character movement animator controller. There we go. So our character animator controller right now, we just have the animator controller and it's being set. We have to implement some things here to get our character controller to display and move in the correct direction. So let's start off by implementing our directions. Right now we have a movement direction from our variable right here. So let's add in our face direction. In order to do that, we're going to need a new vector 2. And we're going to set this just like this. We're going to copy this. And instead of movement direction, we're going to say face direction. And we're going to say the direction the character is facing. And we're going to say here under get and set, we're going to say face direction. And we're going to get rid of our set here because we don't need a set, which means we can do an expressionist body method, and we're going to return face direction. Okay. Oops. Now we are going to come down here to our moving here. If we're frozen, we're setting our move direction. If our move direction does not equal vector 2, 0, we're normalizing it. So now we need to also say if the character is not moving, so actually if the character is moving, so if is moving, we're going to say our face direction, and we're going to do small face direction. Our face direction equals our movement direction. So what we did was we added this movement direction here, this face direction, to be the direction the character is facing, right? And then we exposed it by a public property so that we can only get it. We can't set it. We can only get it publicly outside of this class. And then down here in our update movement, we updated our movement direction. So now let's take our character controller and we're going to implement the update method. And in our character animator controller here, we also need the character movement. So we're gonna do private character controller character movement, and we're say actually M because this is a private field movement, right? And then we're gonna say character movement. Actually, we're gonna copy this animator here, and in our awake function, we're gonna say our character movement equals get component. Now we know that this is going to be filled in because we said, hey Unity, we are requiring you to have this component on this game object that this component is on. So we know it's there. So here in our update direction, we can say m animator dot set float. And what was our float directions that we were wanting to set? We were wanting to set direction X. So the name of the float that we want to set and what we want to set it to. So we're going to say character movement dot face direction dot X. And now we're going to copy all this. Instead of direction X, we're going to do direction Y. Direction Y. Now, if we come in here, look at our character, if we click play, if we go to the left, he's now facing to the left. If we go to the right, he's now facing to the right. If we go up, he's now facing up. If we go down, he's now facing down. And if we release the key, he's still facing the same direction that we last moving in. Okay, sweet. That takes care of our movement. And it takes care of us facing in the correct direction. Now we are going to come in here and I am going to update this a little bit so it makes a little more sense and isn't just all the strings and stuff sitting in here. So first thing we're going to do is we're going to right click here. This is why I like using the writer, because we're going to do this what's called use catch property index. And if you notice, it created this private static read only init direction X animator dot string to hash direction X. And we're going to do the same exact thing with our direction Y. So all this is doing is that when we inherit this class, it's getting our animator and it's turning this string into a hash code. And then when we set our float, we're setting in that hash code and the direction that we want to face. And doing this is just a little bit more performance because we're not passing in strings. We're not trying to get things by strings. We're getting it by the actual hash code. Makes it way more performance enhanced. I think that is all we know. Actually, we're gonna add another method here. So instead of doing this in the update function here, we're gonna create our own function, public, or nope, not public, private, void, because we're not gonna return anything. Update. We're gonna say update. Uh, update movement, right? Because we're gonna have to pass quite a few things into the animator for us to get everything that we're gonna do. So we're gonna create a new variable. We're gonna call this direction, and we're gonna set this direction to our character movement dot face direction. Okay. We are also going to create a balloon here. We're going to call this balloon is moving. Now, if you remember, we have this in our animator. We have this here variable for is moving. What we are getting ready to do is we're going to get ready to set up our animator to be able to play animations for when we're moving. Because right now, our character is not moving. So equals, we're going to say m character movement model dot is moving. Okay, so right now when we play, we can move our character around, but he moves at, if you notice, it just plays the idle animation. He's not actually walking, which looks kind of weird that, his legs aren't moving. I mean, if that's what you want in your game, you can do that. We're just adding a little bit of polish while we go. So we're going to set this up so it makes it really easy. So all we have to do is actually create the animations, right? Um, we're also probably going to need a variable for running. So we'll go ahead and add that in here too, even though we don't have that in our animator yet. It is running. Equals our character movement dot is running. Alright. Um and actually we're gonna say character movement is running and is moving. So what we're doing is there's no reason to pass in a variable that says we're running if we're not really running. Right? If we're not moving, we can't be running. So we'll add that little thing in there. Um, we have no, I'm not doing that one yet. Yep, yeah, we do. We're gonna have a boolean is defending. So when we're moving around. If you remember right in the Zelda games, when you're defending, whatever direction that you're last moving in, when you started defending with your shield, is the direction that you continue to face. So we're gonna kind of implement that here as well. So we're putting them, if defending, we're to say false for now because we haven't implemented any of this logic anyplace else. So we're gonna say if he's defending, we're not gonna update our animator, right? So now we're gonna say if the character is not moving, oops. So if not is moving, right? We got this variable is moving here. Or if the character is defending, so if is defending is true, we're just gonna return. there's nothing to do because we can't defend. We can't defend, and otherwise we're gonna take this here animator set float, and while we are at it, we might as well set the moving variable, right? Um, so we're gonna say animator dot set boo, and what we call this balloon, we call this is moving. So we're gonna set this balloon is moving to is moving. Alright, so is moving is set to is moving. And we're going to create this catch property here for is moving. Um, what other balloons do we want? We're probably going to want an is defending. Right? That's part of the movement. Even though we don't have this, so we'll comment this out because we don't have this variable set up yet, and we don't want to have any issues. I believe that is all we have to do. Oh, to get this going. Alright, so now if we come back here and test one last time because we made some changes, we are just going to see if our logic works. Yes, all our logic completely works. Alright, that is it for this video. Next time going around, I'll show you how to implement your walking animations. See you next time.